Welcome to the session on database management systems. In the first session, that is in the module 1, you have learned about what is data, what kind of data does we have, and what are the different kinds of data that we can handle, right? Now, in this particular module, we are going to learn about what is database management system is. That means how to handle the large volume of the data, and what is the purpose of the database system, how to view the data, what are data models, what are data definition language, what is data manipulation language, what do we mean by transaction data or the transaction management, storage management, database administrator, database users, and overall the system structure. So how the entire system should be maintained in order to capture the data. Now, first of all, before we enter into this, let us understand what is a database management system is. So database management system is a mechanism to collect the data. So hence, it gives you the functionality of collection of interrelated data. It sets a program to access the data. For example, if I have a query to be extracted with, how many participants do I have in this particular session, a set of program will be, access to set, is developed to access the data. Now, database management system contains information about a particular enterprise. That means every company or every enterprise has its own database management system and captures the data. Database management system provides an environment that is both convenient and efficient to be used. So hence, you need to be, capturing the data in a very clear, structured format so that your data has, gives you the answers to the set of queries. Now, database applications. Now, when you just look into the application, in which sector do this particular database is being applied? So, irrespective of the domain, in every sector, the database applications exist. So, in a banking, if you just take a banking sector, all the transactions of the customers will be captured, and that falls into a database management system. So, with respect to the airlines, the reservations which are being made and the schedules of the air flights will also constitute the database management system. For a university, the registration of the students and the number of grades or the grade points that the student has obtained and how many of the students have passed out every year constitutes the database for a university. Now, if you just take a sales or any enterprise which is into the sales pattern, so the customer's data related to the number of products sold or the number of products bought and what are the purchases made, what are the cost of each item constitutes the database management. And what's the stock, right, also constitute the database management. If you just take manufacturing, production, availability of inventory, how many orders are being received and how the end-to-end process of from the production unit to till the delivery of the products, how the supply chain mechanism should go about, right? So that's again which is being maintained by your company over here. Now, human resources, employees, their leaves, their tax reductions, their salaries, all this constitute to database management. So hence, if you see here, there is no one particular area where you can say that we are not maintaining a database. So hence, it's all there as a part of everyone's life. So for example, every individual might be having a database management. For me, it's like, what is the salary that I'm getting? What are my expenses? Am I paying my credit card bills? What is to be paid and how much amount is to be paid? So all this constitutes the database management system. Right? Now, having a very brief understanding about database management system. Now, what a database is and when can we say that it is not a database? Now, the word database, it is actually commonly used across, right? And refer to any of these following. Your personal address book in a Word document, okay, and a collection of Word documents, a collection of Excel spreadsheets, a very large flat file on which you run some statistical analysis functions, the data which is being collected, manipulated, and used. Okay, data used to support the launch of a space shuttle. Now, if you see here, your personal address book in a Word document may not be a database, right? Whereas the collection of Word documents might be a database. The collection of Excel spreadsheets is a database. So that means whenever you're collating certain things together, then only it becomes a database, right? Now, what is the purpose? Why do I need to maintain a database system? So the applications of the database system is that in order to store the data. So I do have multiple formats in which I can store the data. So hence the very first drawback that happens with respect to the database management system is the data redundancy and the inconsistency. I do get the data. For example, if you just take the customer's data alone, so the customer's data is being captured, within the company and along with the dealers and the customer review comments on the social media. So hence I do have multiple file formats. Now, duplication of information in different files. That means I can maintain or I can change the values into different files. Now, difficulty in accessing the data. So I do have more, data which has been kept in silos. So capturing or accessing that particular data would be difficult. Data isolation. So the head office might be maintaining the data in one particular format and the branch offices will be maintaining in some other format. Right? So integrity problems. So the integrity constraints become like, how to integrate with different data sources or how to integrate with different databases. So is another constraint. Right? So these are the drawbacks which are to be taken care whenever we are going ahead and maintaining with the database system. I hope by the end of the session, you had an understanding about what is a database, what kind of data can be named as a database and not as a database, and what are the drawbacks or what are the the important factors that are to be handled when you look at the database management system. With this understanding, let us go ahead and further study still more about this database management system. Till then, happy learning. Database architecture. This is the concept which enables you to understand what is the architecture required for a database management. Now, moving ahead with this database architecture contains the two phases. So it's a model which is based on the structures, and it's a model which helps in maintaining a database system. Now, in the reality, what happens is you'll be having the structures and the processes, and these structures and processes are being processed to maintain in a database system. So hence, a database is a model of structures of reality. The use of a database reflects the process of reality. And a database system is a software system which supports the use of database. Now, whenever it is supporting the use of the database, there are two supporting factors for a database management system, which is called as DDL and DML. DDL stands for Data Definition Language, and DML stands for Data Manipulation Language. So hence, based on the models of the reality contains the structures and the processes, and under the processes, we do have the two, the management, the two supporting systems for the database management. That is nothing but your DML and DDL. So in the DML, it is data definition language, and DML is a data manipulation language. Now, before going and understanding about what is this data definition language and data manipulation language, let us see when to use a database management system and when it is important and when not to use a database management system. Whenever you wanted to have you need to have a storage of the data, then use the database management system. When there is a centralized control of the data where you need to handle over the data at the very centralized process, then you need to use the database management system. So control of redundancy, you don't want the duplicate columns to get repeated with. Control of consistency and integrity. Multiple user support. Sharing of the data across the team members. So the data documentation. So the data independency. Control of access and security where you wanted to give the access of the data to the limited people. So backup and the recovery. So what is the backup process that it is required? So whenever you wanted to handle all this particular parameters or all these particular properties, then it is very important to maintain a database management system. When not to use a database management system. So whenever the initial investment in hardware and software is trying to be too high, or generally the database management system provided is not needed. For example, you don't require to hold on the data. So the overhead of security or the concurrency control and recovery is too high. And the data and applications are simple and stable. So you're a very small firm. So it's a very startup. So in such a case, you don't require a database management system as such, but you need to require a data which is to be captured, but a database management system is not required. And the real-time requirements cannot be met by it. For example, I do have the database with me, but time to time process, I'm unable to meet the requirements. So I do have multiple user accesses not needed. So I'm the only sole proprietor of this particular firm, and I'm the one who is using the data. So hence, in such a case, do not go ahead with the database management systems. Right? Now, under this database management system, we have seen that there are two things. One is the data manipulation part. The other one is the data definition language part. Now, coming to the data modeling part. So, what does this data modeling contains? The model represents a perception of structure of reality. So, what am I perceiving from this particular, perception factor of the reality over here? The data modeling process is to fix the perception of the structures of reality and represent this perception. So, in the data modeling process, we select aspects and we abstract. That means I will select the aspect over here and I will try to, get an abstract of this. So, this is the data modeling process. Modeling system. So when it comes to the process modeling system, okay, so you have a set of processes and those processes are to be modeled to take into a database management. So in order to do this process, generally what we do is we use something called as programming over here to process the data from. So the use of a model reflects the process of a reality. The process may be represented by programs or embedded with database queries where you need to extract some sort of queries based on the tabular format or based on the database which we have collected with. So probably the programmings like SQL will be used over here to extract some sort of queries. Now processes may be represented by ad hoc database inquiries and updates at runtime. So every moment whenever your database is getting updated, so you can extract the queries or you can extract the dashboards by looking at that particular database management and arrive at one particular decision making. Now, having an understanding of what the database architecture is with respect to the reality of process, with respect to the reality of structures, let us see how can we design a database design. Okay. So the purpose of the database design is to create a database in which a model of structures of reality exists, supports the queries and updates the models based on the real-time analysis, and runs efficiently in extracting what is the required query so that you can arrive at a decision making. Okay. So with this understanding of what is this database design, later in the further session, we will be moving ahead with what do we understand from the abstracts point of view. Because in this particular session, we have seen that while we were doing the data modeling process, we select the aspects and we select the abstracts. Now, how can we select those abstracts will be studied in the next session. Till then, happy learning. Database design. Database design includes the abstraction and the classification. In this session, we are going to understand what are the levels of abstraction and how the data design will be, and then we will moving into in-depth concepts of abstraction right now. Levels of abstraction is nothing but the physical level that describes how a record is to be stored. And it gives you a label to that particular abstraction. So what do I mean by this? Whenever I take a database management system, I want the data to be captured in clear columns. Now every column is to be required to be given with a label part. Now this is being enabled by using the abstraction. So in order to write an abstraction in a database management, generally it involves three levels. One is the physical level, logical level, and the view level. In the physical level, we describe how a record is to be stored. For example, I will be storing the record based on the customer ID. And once you define the physical level, you need to define the logical level. Now, the logical level describes the data stored in the database and the relationship among the data. For example, if I'm just capturing the data mentioning the customer ID and the name of the customer, and then the street where he lives in, right? And the city where he lives in, where he resides and where he lives in. So in this, what I'm doing, I'm giving a logical flow about this. Now, if I just give the customer ID as 001, mentioning that it is Alex and resides in some XYZ street and comes from San Francisco, right? So what it is telling you in the logical flow, the very first row and the column which you have defined as a physical level is going to tell you that there is a relation with the next corresponding columns. That is the logical flow that is required to be used with abstraction. And comes the view level, the third level of the abstraction. So it applies the program and hides details of the database. Views can also be hidden based on the security factors. For example, I might have captured the card details coming from a bank. So I wanted to hide these particular details. So in such a case, we can look at the view level, mentioning what columns ought to be visible and what columns should not be visible. Right? So these are the three levels in which the abstraction can be based. So when you look at the view level, right? So if you just look at the view, so the view of the database system, constitutes like this. So you have the first view, which is been hidden with certain columns, second view again hidden with certain columns, and third view hidden with certain columns. And all these are being taken on the logical and the physical level. So physical level, first you'll define, that is, you're going to define the columns. In the logical level, you're going to define the relationship between the columns. And in the third level, you're concentrating on the visibility of the columns over here. So this is how you view the data once you maintain the database management system. Now, based on this particular view, every database management system contains certain schema, okay, and instances. So similar to types of variables in programming language, when it comes for database management system, we have schema, instance, and the physical data independence. Now let us understand what is the schema is. The schema is nothing but the logical structure of the database. That means the database consists of information about a set of customers and the accounts and the relationship between them. Right? So this is the schema over here. Anomalous type of information of a variable in a program like physical schema or logical schema, which gives you the physical level of this database, and logical schema talks about the logical flow of the database over here. And then later in the session, we'll be looking into the different schemas, okay? And then comes the instance. The actual content of the database at a particular point of time is nothing but your instance. So the anomalous to the value of a variable. So on so and so date, at that particular instance, what is the data that is being stored comes to your instance. And then comes the physical data independence. The ability to modify the physical schema without changing the logical schema is nothing but the physical data independence. Application depend on the logical schema. In general, the interfaces of the various levels and components should be well defined so that the changes in some parts do not seriously influence the other parts. Now let us try to understand this. For example, I'm capturing the data of the customer, right? So in the physical data independence, what I do is I need to modify the schema over here. So what I do first, I define the customer ID, the name of the customer, the street in which he resides, and the city where he's residing or located with. Now, for example, I wanted to add the age of the customer, right? So hence I need to add a column over here which clearly tells that this is a physical data dependency. I need to capture this over here, but it should not change my logical flow, right? So that is nothing but the physical data independence, right? So with this understanding of instance, view of data, and level of abstraction, in the next session, we are going to learn about the different types of abstractions and how it can be handled. Till then, happy learning. Abstractions are the data-defined languages, right? So let us try to understand what these abstractions are. So it's very important that the language used for the data representation supports abstraction. Now, what does this abstraction deal with? So we are going to discuss about the three kinds of abstractions right now. One is the classification, aggregation, and generalization. Now, when it comes for classification, in a classification, we form a concept. So in a way which allows us to decide, whether or not a given phenomena is a member of the extension of the concept or not. Now, for example, I wanted to go ahead and create a concept about the customer's data right now. Now, whenever I just take the customer's data, I wanted to capture the customer name. So customer name is a concept over here. Now, whenever I create a customer name, whether this customer name is connected with the extensions of Tom, Edie, Nick, Liz, Zoe, or Lucy. right? So this is how the classification comes with. That is, the customer name, which is a concept, in a way decides whether or not a given phenomena is a member of the extension of the concept or not, right? So this is how we create the classification abstractions. Now coming to the aggregation. In an aggregation, we form a concept from the existing concepts. The phenomena that are members of the new concept's extension are composed of phenomena from the extensions of the existing concept. Now, for example, if you just take an airplane, so airplane is a concept which comes out with a wing, engine, and the cockpit. So the extension of this aggregation might be the crew management, right? Might be the maintenance, right? So this is called as aggregation. That means all put together will lead to a concept, right? So this is the aggregation abstraction. Now coming to the generalization. So in generalization, we form a new concept by emphasizing common aspects of the existing concepts, leaving out the special concepts. Now, for example, if you just take an airplane, okay, so what is this? This is a common concept, right? So this is a common aspect, traveling through an airplane. Now, in this particular common aspects of existing, so what are those existing? So it's a first class or economy or a business class. Now, what you are doing here, you are creating a new concept. What is a new concept? New concept is nothing but the segregation of the seats based on their travel pattern or a purchase pattern, right? So you're coming out with a new concept by emphasizing on the common concept. What is the common concept? You're segregating the customers, but leaving out the special aspects. So the special aspects are being left out over here. So this is the generalization concept. So in the generalization concept, what happens is there might be a subclasses which might be overlapping. For example, first class and the business class. And in the same way, subclasses may have multiple superclasses. So, like if you just take the same thing, long, lengthy seats, right? Lengthy seats or, stretchable seats. Right? So this is the multi-super class. So hence it is motorized vehicle, trucks, helicopters. Now airborne vehicles, helicopters and gliders. So like this, what you'll be having is you'll be having a multiple super classes also. So this is called as the generalization concept. So hence under the abstraction, we have seen the first one, which is called as the classification. The second one is called as the aggregation. And the third one is called as the generalization. So these are the abstraction classifications that can be studied. In the next section, we will be going ahead with the database terminology. Till then, happy learning. Database terminology. Before we go into the understanding of SQL and the database and the further topics, let us understand the database terminology as we are clearly aware about the architecture of the database management systems right now. Now, moving into the database terminology, we are going to learn about what are data models, keys and identifiers, integrity and consistency, triggers and stored procedures, null values, normalization, surrogates with respect to the things at names are being confined. Now, going into the data model. A data model is the notation for writing an expression. Whenever a data model is to be written, it captures three things. One is the data structure, integrity constraints, and the operations. Now, when it comes for the data structures are of different types. All the data models are to be defined based on the data structures. Generally, there are three types of data structures. One is the attribute type, the second is the entity type, and the third is the relationship type. Now, when you just look at these attributes, so an attribute type is based on a one particular attribute or one particular feature or one particular variable is called as a attribute type. And the entity type data structures are those which captures the entire data related to a one particular entity or one particular enterprise. And the third one is called as the relationship data types, where you are trying to establish the relationship between the various columns in the data type. So hence, the data models are the notations of the defined data structures. So hence, if you just look over here, the data models takes the attribute type. So in this particular example, the attribute type is nothing but your airline column alone. So if you are just looking at the airline column alone, so then it is nothing but your attribute type. And entity type is the data related to the flight and the schedule. And the relationship types is nothing but the relationship between certain columns of flight schedule and the department airport. Okay? So these are the data structures with respect to the data model is concerned. Now, what are data constraints? So constraints are nothing but the limitations. So constraints express the rules that cannot be expressed by the data structures. So static constraints apply to the database state and dynamic constraints apply to the change of database type. So hence, for example, all flight scheduled entities must have precisely on depart airport relationship. Obviously, because the scheduling of the airport, the scheduling of the flight happens more on the departure time of the airplane, right? So hence, there should be a relationship between these two. That is the first point. And the second point is these are controlled. So if there is a scheduled time, then the department of the airport will have the same scheduled flight. right? So this is within a short duration of time, only this particular flight has to be departed. That means you have a control over here on by expressing certain rule, right? So this is called as a constrained data model. And the third execution of the data model is called as operations. So operations support change, or what are the changes in the data. For example, if I wanted to go ahead and insert a new flight which is being scheduled, so in such a case, we use an operation called as insert. So insert the flight schedule of 97 with the delta variant with 258. So what you do here, select the flight, the weekday from which the flight schedule data is being confined, and which airlines it is, right? So these are the operations which are being carried on in a data model. Right? So if you just look at the operations from a program specific point of view, so you prepare a OpenC and repeat to fetch the flight number along with the weekday so that you can close it off by coming out with a decision making. So these are the three types of data models. One is nothing but your data structures, what kind of data structures it can handle. The second is your constraints handle, and the third one is your operations. I hope with this you had a clear understanding of what a data model is. See you in the next session. Welcome to keys and identifiers. Keys and identifiers are the unique constraints. A key is a terminology which is being confined to a one particular column. So the key on flight number in the flight schedule will force all the flights to be unique in the flight schedule. That means, so whenever I just give a key number, that is, this is the key number. So what this key number specifies is this key number is related to the airport code. Similarly, this key number is related to the name of the airline. So, and key number is related to the weekday, in which week, and then similarly it is related to the price. So hence, keys are identifiers which will help you to identify the other columns or the other data based on your key factor over here. Now, coming to an example of a keys and identifiers. For example, if I just take the usage of a mobile phone by the customers, I say that customer X will like these particular features in this particular brand of mobile. Right? So hence, this is a key or an identifier to identify the data clearly. Now, coming to the next terminology of understanding, which is called as integrity and consistency. Now, integrity is the factor in the model reflect of the reality, whereas the consistency is the model without internal conflicts. Now, whenever it comes for the integrity talks about the interconnectivity of the columns. So a flight, a schedule cannot be a null. So because it models the existence of an entity in the real model. And in the same way, there should be a consistency, a common sense of capturing the data. That is, it's a common way of capturing the data from the beginning. Right? So a flight in Depart Airport must exist a flight schedule, because it doesn't make sense if the flight schedule doesn't have an entry in the entity model over here. Right? So that talks about the integrity and the consistency. That means there should be a connectivity between the database whenever you look at the two different data sources, and the consistency should exist over there. Now, coming to the triggers and stored procedures. Triggers and stored procedures. Triggers can be defined as the enforced constraints on the database. So to define a trigger, you need to find it out if I'm going to delete one particular column from one particular database, what should be the action? So what should be the triggering action to retrieve it? So that is called as a trigger. So while you are implementing the triggers, there should be some sort of storage to be maintained. Right? Coming to one more terminology called as null values. Now, whenever you look at this particular